Hello, everyone. Welcome back, and a huge welcome to those who are attending their first Mud Talks. Tonight, we have AI, Ethics and Society, a primer with Daniel Bashir, class of 2020. My name is Vanessa Chu, Assistant Director in the Office of Alumni and Parent Relations. We are excited to bring you another year of Mud Talks, and we hope you and your family are safe and healthy during this time. This talk is being recorded and will be distributed after the event. Please feel free to type your questions in the Q&A box, not the chat, and we will try to get through as many questions as we can. Now, to briefly introduce our speaker, Daniel Bashir is a computer science and mathematics graduate from the class of 2020. During his time at MUD, he worked in 2 different labs doing machine learning research. His industry experience includes internships such as as a software engineer and working as an applied scientist on machine learning platform and personalization teams at Amazon. He will join an AI chip startup as a machine learning software engineer in the fall. Now, I'm going to turn it over to our speaker, Daniel. Take it away.
Hi, everyone. Give me just a second to share my screen. It's been a very interesting year, I think, for the AI community. And it seems like a pretty useful, interesting time to be considering some of the questions around the ethics and societal implications of the AI technologies we're building. Among a couple of the things that happened over this past year were the release of an incredibly powerful language model by OpenAI, the exiting from Google of one of the most important AI ethics researchers in the industry, along with a number of other things kind of going on alongside that. So really, it's just a very interesting time to be involved in or paying attention to any of these topics. Today, I am really hoping to give you more or less a surface level sense of what's been going on. I will talk a little bit about where AI is today, how it's being used, why we might even want to be thinking about these things in the first place. I'll talk a little bit about responsible AI. I think that's really become a bit of a buzzword as of late, and definitely for good reason. I'll spend a little bit of the later part of the talk talking about 2 kind of specific issues that I think are pretty interesting. One on recommendation issues, recommendation systems. If any of you have watched The Social Dilemma last year, it's become a little bit of vogue to talk about this, so I figured it made sense to spend a little bit of time on that. And the second on legislation. So this year in particular, there's been a lot of advancement in attempts to legislate AI systems. And so I want to talk about one specific piece of legislation we can look at and some of the issues that folks have started to notice with it. And then we'll go ahead and wrap up. I guess Vanessa already gave me an introduction, but just to talk a little bit about myself for a second, as she said, I did CS Math over at Harvey Mudd, some engineering and science internships at Amazon, and soon we'll be starting at Samba Nova Systems on the ML team. Outside of all of that, I do like to write and edit, and many of the ideas in this talk today have kind of come from spending around 2.5 years working on this sort of online AI-related publication where we try to get researchers to explain their work to the general public and think about the impact of their work on society. So that's called Skynet Today. I've also been involved on the editorial team over at The Gradient, where we do something very similar, but with a little bit more of a technical focus. So that's pretty much me. Just as a preliminary, I want to take a second to talk about what we mean by AI. I do want this talk to be pretty much entry level, and I suspect that a lot of you have pretty refined notions of what this actually means, but I do want to spend some time clarifying that. So we usually like to define artificial intelligence not as an actual noun in terms of the thing we're building, but rather the kind of scientific or engineering field of developing intelligent machines and intelligent computer programs. You will find it really drives AI people up the wall when you say an AI, and that unfortunately occurs a lot in the media. You'll see that in many articles. But when you hear that, what that really just means is that someone built a machine learning system or a predictive model. Now, what artificial intelligence is not is images like you see in this slide, which also drive many of us up the wall. Just to give you a sense, though, I think it's a little bit important to drive this point home by thinking a bit about the way that AI gets represented in the media. I think that there's ways in which there's a lot of hype around AI, but then there's also a lot of pessimism. And in the two efforts I've been involved in, one of the things I really try to focus on is giving balanced perspectives, especially from folks who have a fair amount of knowledge in the area. So along the last year, one of the things I mentioned was the release of this very powerful language model, GPT-3, from OpenAI. Now, all a language model really is something that's kind of trained to predict and generate text. And GPT-3, being trained on an absolutely stupid amount of data, is able to start with just a very small amount of context. You can start it off with the beginning of a sentence, and it can go ahead and write paragraphs and paragraphs for you. Now, it boasted pretty impressive performance, and it kind of blew up last year when a couple of people on Twitter noticed how they were able to ask GPT-3 to generate like front-end code. And it was not entirely perfect, but mostly bug-free. And with only a couple of small tweaks, they actually had like working JavaScript code. And so we saw just a proliferation of news articles in places like the New York Times and the MIT Technology Review. And at the very beginning, there was so much hype around it that I think its capabilities were pretty overstated. So in this New York Times article, I think there's definitely a lot worse than this, but there's a little bit of anthropomorphizing going on here, which folks in the AI community try to be really careful about. Other things that people worry about are whether AI is going to take your job. GPT-3 introduced those worries in particular. There were people who are worried that my front-end development job is going to be lost because this thing can generate code. At the moment, that's probably not too big of a concern, but I can definitely understand why people might feel that way. And here are kind of two, I think, even worse cases. So I mentioned the case of saying the phrase an AI or an artificial intelligence. We can also see these articles saying AI can now design cities, should we let it? Again, those are kind of two cases of a significant amount of anthropomorphizing that I think really is not great in terms of giving people a good sense of what the capabilities and limitations of AI technologies are. I think that it's really important to understand that while AI technologies can do a great deal, they are fundamentally at the moment machine learning and predictive models. So the very basics, if you think about it, are I can train a machine learning model to predict what the price of a house or a car should be given some characteristics of that house or car. Now, there are much, much more impressive feats like GPT-3 that we can see coming out of that, but really it's just very complicated combinations of ways to do this sort of task. At the same time, we've seen a lot of skepticism. So there's been a great deal of activism over banning facial recognition, and facial recognition has been a particularly controversial technology. Really, this has kind of been around for a while. So one of the first large-scale instances was back in 2001, when facial recognition technology was actually used at the Super Bowl and scanned a lot of the people who were there. That resulted in sort of a lot of news around what was going on. People were not too happy with that. I do think that a lot of the skepticism around facial recognition is warranted and good. And there have been a number of instances arising where facial recognition goes awry. I think the fact that there's articles like this, though, definitely demonstrate the need to have conversations about the role of this. I think that there's a strain of thinking that goes, we should absolutely just ban facial recognition, and this technology is absolutely too dangerous to be used out there. And I think there is great merit to those opinions, but I think there's also another side to that debate. And so when I view these kind of dogmatic, let's totally ban facial recognition ideas, I think that there needs to be a little bit more balance in that conversation. Another really great piece of activism last year that I view as skeptical is The Social Dilemma, just because I think its depiction of the way recommendation systems affect us was really, really bleak. I do think that it was a great movie. It showed a lot and demonstrated a lot about how the recommendation algorithms on Facebook, on YouTube, on many different platforms that are designed to attract clicks, to make us spend more time on the site, can cause us to waste our time or watch videos we might regret. And really, the time that we spend on those platforms as a result of the recommendation algorithms might not be well spent, and it might not be in our interests. That being said, I do think that the way the movie kind of painted all of the way this was going on was pretty dark. I do think that we do have a little bit more volition than might have been portrayed in the film. That being said, I think it's an incredibly important issue. I will talk a little bit about this later. And getting onto the reality, so this is a little bit of a mini self-plug, but just in terms of thinking about, what is the balance? How do you kind of cut through the hype towards understanding what's really going on with AI systems? And I think that it's a good idea to, if you're interested in these topics, definitely, consume the news, understand kind of what's going on, but also really carefully read what's actually going on in the articles and not just their titles. I think that it's a pretty common thing in media to have somewhat sensationalizing titles that can belie the fact that what's actually going on in the article, what the actual piece of news was, is maybe not as extreme as the article might lead you to believe. So for example, with GPT-3, I roped a friend of mine into writing this article about how while GPT-3 is really a breakthrough in AI, and I think more a feat of engineering than anything else, to be honest, despite the fact that it manifested as a scientific breakthrough, it's absolutely not going to come from for your job. There's a lot that it still can't do. I wanted to kind of give an example of what actually using GPT-3 looks like. So here's kind of an example of what the OpenAI API looks like. And so you can interface with GPT-3 in a number of ways. One of the really interesting things that came out of it is, as I've said, you can prompt it with just a very short sequence of words. So in this case, the only words I put were "this week, Elon Musk." And GPT-3 proceeded to write a pretty short article for me. And you can see that is kind of complete even with this image Tesla. It didn't continue going on from there. And if we actually read through what's going on here, it doesn't make total sense, but it's definitely pretty impressive. I think the fluidity of the language that is occurring there and all of that. When OpenAI kind of came out with GPT-3, one of the really interesting things was that they found it had this capability of learning to adapt and solve new tasks that it had never seen before. That's a theme we'll return to a little bit later, but in terms of the more, I guess, the views of AI in terms of working towards something like an artificial general intelligence, for example, that a lot of people tend to think about, a lot of folks have been wondering if this is a major step forward on that front. And there's been even more recent research that I'll kind of mention later that's been a step in that direction as well. Some more things to think about. One big worry when GPT-3 was released was, hey, this thing can generate lots of text very cheaply and easily. Could GPT-3 potentially exacerbate the attacks on our epistemic commons? Could it enable people to create a whole bunch of chatbots, deploy them on Facebook, on Twitter, on other social media sites, and just generate massive loads of disinformation? There's a lot of worries about this, which I think are worth taking very seriously. And they've been studied a little bit, but many of those worries at the moment, at the very least, are pretty theoretical. And while the studies have been done, so far they really haven't generated anything conclusive. If we also look at some of the things going on around facial recognition and the bans and some of the legislation, one of the things we kind of have to contend with is that it's really difficult to legislate AI technology. And I'll get a little bit more into this with a specific piece of legislation later. But in the United States, for example, we've tried to attack the problem with facial recognition, with biometric privacy laws. But the problem is there still remain a lot of loopholes. There's a lack of transparency around the algorithms we use. The legislation is very difficult to enforce. And despite bans, for example, in a number of cities, so like Pittsburgh, Boston, Madison, Wisconsin, Alameda in California, police have found that they're still able to use facial recognition. And there's a couple of things there that are pretty interesting. I think that one of the big things here is we've seen from the various meetings on Capitol Hill that legislators, at least a couple years ago, didn't seem to have a great understanding of how AI technologies worked. In fact, at the time, it was almost embarrassing, I think, to watch them try to question all of these tech giants. I think they're getting a little bit better and there's been a lot more attention, but at the same time, when it comes to actually getting down to brass tacks and drafting legislation, there's a lot that's really, really difficult to do. So, for example, Pittsburgh passed a ban on facial recognition. I believe this was back in September. And one of the people who was in the city council noted that there's this part of the legislation that says it doesn't apply to using software produced or shared by other police departments, which obviously doesn't stop the police from still using facial recognition. So there remain lots of loopholes and little tricky instances in defining legislation around these things that I think we're still trying to work on. As we go on, I want to spend a little bit of time just talking about some general features of AI technologies, some of the advances we've seen in a little bit more detail, and the uses of the AI technology before I get into the rest of this talk. Some initial takeaways and why I think we kind of care so much about this right now is AI systems are becoming a greater part of our everyday lives. So the inability to kind of scale practices and the way that they're done by humans. So for example, reviewing job applications, conducting interviews, looking for potential criminal activity in a video or an image means that we want to deploy AI systems to handle those tasks because automating that scales much, much better. But the AI systems that we end up using, many of them are marketed as having really high accuracy or doing a good job at something. And as a result, we end up with these kind of black box algorithms. So something we'll talk about a little bit later, but the inscrutability of these algorithms kind of makes it difficult to understand whether they're making the right decisions for the right reasons. Another kind of important thing to think about is that while AI systems have made impressive progress, they are very limited. So many of the AI systems in use today and things like facial recognition have been trained on specific data sets, but AI systems suffer from a very common problem known as distribution shift. And so whenever I have a machine learning model, say I want to train it to predict whether a face belongs to a certain person, it can suffer from a kind of bias that is imbued by the fact that I train it with a certain data set. And if I'm not careful about that data set, for example, if that data set mostly contains Caucasian people, if it mostly contains East Asian people, for example, then my facial recognition algorithm might become much better at predicting who a face belongs to for one demographic group than for another demographic group. And as a result, you might see it making more mistakes for a certain demographic group. If that AI system then gets used in a context like policing or something of the sort, you might see disproportionate impacts to certain demographic groups because the AI system is making more mistakes with a certain demographic group. And people are then making decisions based off of the output of that AI system. And this kind of leads into the idea that even the limited technology we have today can be used or marketed in troubling ways. So for example, we've seen deepfake technology, which is able to generate now reasonable looking images and videos used to scam people. There are even worse uses of it that I thought were not appropriate to include in this talk, but you can kind of just imagine. Another thing I think that's important here is though that too much skepticism, on the other hand, is pretty undesirable, and legislating AI systems is quite tricky. So I think that one of the big reasons AI researchers have urged people to slam the brakes on regulation just a little bit is that it's really difficult to predict how AI systems are going to work, and over-regulating too early can restrict them from making incredibly important advances. Another problem here is that inscrutable AI systems that I've talked about a little bit pose a number of potential harms. So these images are actually from a very recent article about basically almost racism in medical AI systems. And this person found that AI systems, when used in a clinical context, can learn to identify the self-reported racial identity of patients and not only identify patients in the training data, but extend its ability to identify the race of people beyond the data that they were giving it. And what's even worse than that, I think, is the fact that the researchers were not able to identify precisely what that depiction of race in the AI system looked like and how it was forming that picture of the race of people, which I think calls out the really large importance of interpretability in understanding AI systems. As we've gone through those takeaways, though, let's talk a little bit just about the advances we've seen in AI systems so we can get a better sense of what's going on. I've already presented a little bit about how they're portrayed in the media and some issues, but let's talk about what they can actually do. So the AI index, which is a great source of kind of understanding what the latest trends and developments are, has told us that AI systems are now kind of in the land of generative everything. We've got deepfakes, generative adversarial networks. We can generate text, audio, images to a pretty high standard. And it's believable that those text, audio, images might have been created by humans. Facial recognition algorithms in particular have become very powerful. AI systems are used more in decision-making systems, like in policing and resource allocation in many areas. We are seeing advancements into different paradigms of machine learning. I won't talk too much about this, but semi-supervised learning, which you can look up if you're interested, and large-scale pre-training for language models and reinforcement learning agents has become a big thing. Another really important trend is the democratization of AI technologies, as well as a conversation over what release norms should look like. I talked a little bit earlier about the potential disinformation threat of a language model like GPT-3. About a year after that was released, an open source organization called Alumni produced an open source version of GPT-3, a little bit smaller. It's called GPT-J. You can access it for free on platforms like Hugging Face. And the fact that it's open source made people very worried. But Alumni on their hand has some counter arguments as to why it's probably a good idea actually to have such a powerful language model open sourced. And a lot of those arguments are around the scientific study of language models and the interpretability. If we take a second just to look at the uses and domains, we've seen them in business functions, healthcare, policing and criminal justice, social media, art, transportation. And as we kind of think about the advances that produced all of this, one of the really big moments was something called the ImageNet moment that occurred early in the 2010s. So there is this data set called ImageNet, which is a very large scale image recognition challenge. It contains millions of photos, and there's a whole bunch of different classes of things like cat, like dog. And the goal is for an algorithm to predict whether this image contains a cat, a dog, a pencil, some other object. And this was the first instance where a neural network, specifically something called a convolutional neural network, and neural networks had been in development for decades, actually achieved incredible performance on this benchmark. And so this was kind of called the ImageNet moment and marked a sea change in terms of the use of AI systems. And so this is kind of when the deep learning moment began. Later on, natural language processing kind of had its own ImageNet moment at the same time. To give you an example of the sort of generative technology we see, I sort of messed around a little bit myself with this open source thing that is able to generate images based off of text. So you can kind of see two images here. You can just give it a sentence, and over time, it will be able to produce images for you. Here's another very fun example of a child looking at a pixel art version of Mona Lisa. To give you a depiction of what deepfakes look like, this isn't an actual video, but you can see at the very least that what's being produced is reasonably high fidelity of what Obama actually looks like. In addition to that, we're seeing a lot of uses for AI in medical contexts, some definitely positive uses in terms of trying to detect COVID-19 through coughs. There's been a lot of hoopla around trying to use AI to help with the COVID-19 pandemic. Unfortunately, it seems like a lot of the attempts haven't been super successful, but there's definitely hope that if we continue working on medical AI systems, they might be able to help us in a future pandemic. Hopefully that type of thing doesn't occur again anytime soon. Now that we've talked a little bit about the advances and some takeaways from AI systems, I do want to spend some time talking about the growth of AI. This is kind of just justifying why these topics are so important in the first place. So we can see that commercialization has experienced a great deal of growth. So you can see that the proportion of AI startups versus all startups has increased significantly. If we look at the venture funding for the AI market, it has also increased significantly. And if we look at the political attention, machine learning and artificial intelligence have been mentioned much more in Congress in the recent years. Additionally, the term usage of all sorts of terms related to deep learning and AI have increased quite a lot. and the business impact and influence has grown greatly. I don't want to spend too much time on the specifics here, but just to give you a sense of what that growth has looked like. It's become a pretty massive thing in society as of late. Now let's get on to what responsible AI kind of looks like. Again, I've mentioned that this is a bit of a buzzword, and for good reason. And I want to recap a couple of notes about AI systems and really the call for the need for something like responsible AI. So one of the big issues I mentioned is this idea of distributional shift, that AI algorithms behave differently from training and in the real world. So as I said, if I have a facial recognition system, it might operate differently when I'm using it to observe citizens in an actual real world scenario versus when I trained that facial recognition system. It might degrade in performance and it might get things wrong a lot of the time. And I really think that this idea of distributional shift is one of the key ideas underlying a lot of what's going on around responsible AI. As we develop AI systems, a lot of those parts of developing them involve value judgments. So when we select training data, for example, when we select features, we are kind of making a value judgment about what things about a person, for example, are important in, say, predicting criminality, if we are to create an AI algorithm for that. In algorithms for criminal justice, where we try to predict things like criminality, even just saying, I want you to have high accuracy in predicting criminal behavior kind of creates a value judgment on our side of, okay, what does that actually mean? We have to make some kind of implicit value judgment about what criminality looks like. And that kind of ties into the fact that machine learning algorithms, despite the fact that we have a kind of automation bias, are not objective in any meaningful sense. They are skewed by the models themselves. Models have to make inductive biases, presuppositions about the world before they see any data in order to actually learn anything. And the data we feed them also gives them a skewed vision of what the world looks like, so that when they get applied to real world situations, those biases kind of stick around. Another important point that I talked about a little bit earlier is this performance interpretability trade-off. So if you want to develop algorithms that have really high performance on tasks like identifying faces, for example, we often have to develop very complex machine learning algorithms. And what's unfortunate is the more complex they get, the less possible it is for us to understand what the hell they are doing. And to just thinking about what actually developing AI responsibly looks like, there's been a lot of talk about responsible AI frameworks and what that should mean. So Brookings, I think, has a good summary of this in that it seeks to make AI systems transparent, fair, secure, and inclusive. Those are all pretty important things. To give you an example of what the methodology looks like, we can look to Google AI's responsible AI practices. This involves things like human-centered design. So thinking about the person who is going to be using or affected by your AI system at the end of the day, thinking about very carefully the metrics you want to use for training and monitoring. What does accuracy mean in this context? If I have a facial recognition algorithm, how important is a false positive, falsely identifying someone as a subject when they're not in fact that person versus a false negative? What's kind of important there? Examining your data, am I feeding my algorithm more Caucasian, more East Asian, more South Asian faces than another demographic? How does that balance out? And understanding the data set and model limitations. And then finally, of course, testing your system to understand how it performs on out of distribution data that it's never seen before. And finally, when it's out there in the wild, monitoring it for degradations in performance and updating it to make sure that dangerous things don't continue to happen. There's also a really important sense of the ethical discipline in AI versus non-cognitive technologies that I want to touch on for a second. And you might have seen a lot of these topics like human-centered design just in engineering design classes or in designing technologies in general. I think what's important to note about AI technologies is that even if you do everything right, besides the potential safety, the specific behavior of an AI system might not be predictable. Those two key aspects, the unpredictability and inscrutability of AI algorithms, poses a real challenge to dealing with them. And not only must we identify the safe behavior of an AI algorithm, but we need to identify what it's trying to do. I think that understanding that AI systems are doing the right things for the right reasons is a very important thing. To think about, though, just kind of a case study in a call for responsible AI, what it looks like, I do want to give us kind of an example of an irresponsible use of an AI system. So I mentioned that this has been a very interesting year for AI people, and in part, it's also because over the past year and a half, we saw the first 3 cases of African-American men being wrongfully arrested because a facial recognition algorithm made a mistake. Turns out this wasn't actually the first known case of its time. At the time, it was thought to be, but Robert Williams in Detroit was accused of being involved in a shoplifting incident and was arrested. Now, what kind of happened here was in a particular store where Williams was accused of having shoplifted something. There was some video footage of a robber in the store. Now, somebody who was helping out the person in the criminal case went over the video footage later on and forwarded it to the police, who had access to a facial recognition algorithm. After they used that facial recognition algorithm, what the police did was they took the closest match, which turned out to be Robert Williams. They took his image of his driver's license and added it to a kind of 6-pack lineup of suspects for the case. They then showed it to the person who submitted the video footage. Now, what I think is really important is that this is not the person who was present at the incident. She reviewed the video footage and sent it to police, but was not there in person. They included Williams' image among the 6 photos that they showed to this person, and she chose Williams as who she thought the criminal actually was. And so they went to Williams' house and arrested him without giving him very much information about why they did so in the first place. And what's striking to me about this case is not that the facial recognition algorithm made a mistake or that it was biased. I think that's something we should expect at this point. A couple of years ago, Timnit Gebru, one of the most important AI ethics researchers in the space, published a study called Gender Shades. And this pointed out how many of the facial recognition algorithms that are in production from companies like Amazon, Microsoft, and IBM demonstrate bias. They perform much worse for folks who are darker skinned and female versus lighter skinned and male. So I think that's something we should expect. What I think is more troubling is the fact that there wasn't a good amount of due diligence done on the part of the police. So for example, they included Williams' photo in this 6-pack photo lineup without doing any more investigation into Williams' background. It turns out that Williams had actually never been to the store in question in his entire life. And had the police done a little bit more due diligence, this might never have happened. On top of that, as I mentioned, they showed these photos to someone who is not there at the incident in the first place. So I do have questions about whether she would really have been able to correctly identify the person. The other thing I think is that there are definitely flaws in our reasoning. And I think the fact that they included Williams in that 6-pack photo lineup, the article unfortunately doesn't give us too much detail about the precise information beyond that was communicated between the police and the person who identified the suspect. But the fact that his photo was included in that lineup could indicate sort of confidence on the part of the police that it's probably pretty likely that he would have been there in the first place. Now, as we've kind of just given a sense of what responsible AI looks like and giving you that case study, I do want to talk about 2 topics that I think are pretty interesting. The first is going to be another sort of responsible AI topic, something that people find troubling, and the second is going to be around legislation. So recommendation systems have become a sort of hot topic recently, especially with the release of The Social Dilemma, podcasts like Rabbit Hole from the New York Times, and the finding that a lot of people really feel like they kind of regret many of the videos they watch on YouTube or spend too much time on social media. But just to take a second to talk about what a recommender system is, the goal is to recommend products or content that might be interesting to users. And what interesting means is kind of ill-defined, right? So the way that you figure out what that is predicting how content will affect engagement. And engagement can mean a lot of things. It can mean the watch time on a video. It can mean the number of clicks on a website. It can mean the amount of money you spend on an online marketing platform. And then you prioritize content that should lead to high engagement based off of experiments. The way you tend to measure this is by performing A/B tests on users. And an A/B test is basically a sort of trial where you sort users into 2 buckets. So if you want to test a new recommendation system versus what already exists on your site, then you sort users randomly into 2 groups. the sort of A group experiences what is already on the site. The B group experiences the new recommendation system or whatever changes to your site you want to make. These groups are kept separate, and you test that out for a while, maybe a couple of weeks, and you examine, okay, according to the engagement metrics I'm looking at, the amount of time spent on site, the money spent by these groups, which one fares better? And then you kind of make decisions as to how you want to modify or tweak your recommendation systems. And to give some examples of how this has looked in the real world, the New York Times, for example, actually uses recommendation systems for their ad placement and for articles. So they conducted something called Project Fuels, where they basically built prediction algorithms with large amounts of data that were collected via crowdsourcing. So they actually asked users how they felt after reading articles, and then basically created something called a predictive targeting algorithm and tried to figure out, okay, how can we develop this prediction algorithm that is able to serve people the type of content that we think is going to make them feel a certain way. I mentioned earlier a number of, excuse me, qualms about recommendation algorithms. So there's ethical implications of potentially influencing user behavior whenever you show users a certain piece of content that does influence their journey online in a certain way, and there might be unintended consequences of that. In addition, there's the question of time well spent. If I'm spending 7 hours on Facebook during a day, and that is in part driven by the recommendation algorithm, is that really a good thing? And the fact that these algorithms are also inscrutable. It's hard to know what reasons they have for showing us the content that they are showing. And Mozilla recently conducted a study on YouTube that found that a lot of the users they surveyed really regretted much of the content they were being fed by YouTube. I want to take a second and talk about a specific piece of legislation just to drill home how difficult it is to go about solving some of these issues. So to give you a background for why people are even thinking about legislating AI technology, and that's been sort of a big thing over the past year, we've already seen how there's increased attention to AI by governments. There's been another number of troubling uses of AI, and there's been public backlash against things like facial recognition. I've already mentioned the inscrutability of AI systems and the lack of insight into AI-based decision-making. Many members of Congress, people in the House of Parliament, feel really icky about that. There's also some other troubles, though. We want to balance innovation with the oversight we'd like to have over AI systems. And there's also geopolitical rivalries and senses of AI nationalism. And if we look at kind of specific instances, though, like, do we think this should be allowed? So one of the most controversial cases of facial recognition has been this company named Clearview AI that scraped billions of publicly available images off of social media sites and used them to train an incredibly powerful facial recognition algorithm that it then sold not only to police, but to stores like Macy's that were found to be using them in their stores. When this news came out, Clearview actually said that it was going to restrict selling its algorithm only to law enforcement. But with this tool, a policeman could just take a photo of you with his phone and use Clearview's app to look up a match for you and probably find photos, videos of you that are on Facebook from maybe 10 years ago, for example, if they were ever publicly available. Another thing that seems pretty troubling is the fact that there's a lot of companies who are creating systems for hiring. For example, HireVue has been developing AI technologies that purport to be able to tell from a video of a person how good of a hire they're going to be. And a lot of this is based off of really bad science. And emotion AI researchers really think that they're getting a bad name from this kind of work. Another thing that's troubling, though, is that as AI systems grade your interviews, the companies that are putting out this AI technology are under no legal burden to actually explain how these systems work. And as AI systems become even more advanced, you can see this becoming a larger issue. To think about what's been done, there's been a proliferation of principles from OECD, Google, DeepMind, Microsoft, a whole bunch of places, and attempts at AI legislation. We're going to talk about a specific one now, which is the draft EU Artificial Intelligence Act. Before we get into that, though, in terms of what's actually ahead for all of this, there's a great deal. I think that operationalizing the high-level principles we've seen. thinking about what counts as explainable or transparent, for example, or socially beneficial, appropriate human direction and control, and a bunch of other things specified in them is going to be incredibly important. Determining what to legislate and how, and then refining current attempts at legislation are all going to be very important. So if we look at the draft EU Artificial Intelligence Act, there's a couple of specific objectives, and I'm going to have to go through this a little bit quickly just for the interest of time, but there's a lot kind of going on here, and this is a very ambitious act, and it places a lot of restrictions on AI systems. So the first is to ensure that AI systems are safe and respect existing law. They want to facilitate investment and innovation in AI. We talked about that balance earlier, to enhance governance and effective enforcement of existing law and fundamental rights and safety requirements, and facilitate the development of a single market for lawful, safe, and trustworthy AI applications. And if we think about the provisions that are here, this is a very wordy slide, so if you'll bear with me for a little bit just to talk about, I think, what the key things here to think about are, there's a couple of different provisions in it that I think are particularly important to look at. So the first one, that prohibits manipulative systems that deploy subliminal techniques beyond a person's consciousness to materially distort a person's behavior in a manner likely to cause harm, looks targeted at things, for example, like recommendation systems that might change the way you act. It prohibits systems that give trustworthiness scores. So for example, if you wanted to use a hiring algorithm, so something that scans your video and looks at your face to decide whether you're trustworthy or not, that's going to be banned by this act. It bans the uses of some real-time biometric systems and requires providers of what they call high-risk systems to provide management systems. There are also transparency obligations and a required public database of these so-called high-risk AI systems. I think there's a couple of positive steps here. So for example, they distinguish high-risk AI systems from other systems. The requirements differ by risk level. There are full-on prohibitions of what they view as unacceptable harms and uses, and there's facilitation of societal scrutiny via transparency obligations and this public database of high-risk AI systems. But there's a couple of issues, and there's a great study that came out from Vila and Borgesius recently called, that's about this EU Draft AI Act. And among some of the things that they point out and that I've been thinking about too, is that language issues within the legislation make it really difficult. So for example, what exactly constitutes psychological harm? They talk about the subliminal techniques beyond a person's consciousness that might occur in a way likely to cause harm, but how you distinguish a kind of harm threshold occurring all at once from accumulated harm over time, for example. The Act also doesn't take into account combinations of user dynamics in an AI system. So for example, if you think about discriminatory ratings on a platform like Yelp, and then how that gets treated by a recommendation system, that might not be great. There's a number of loopholes. So for example, vendors could sell reconfigurable systems that could then be made to be manipulative. Another thing that's really tricky is in the social scoring algorithms they talk about, the idea of leading to is a little bit unclear. So when we develop AI systems like self-driving cars or ones that are used in systems along with people, it becomes a little bit difficult to allocate responsibility. If we look at the biometric provision limitations, it only limits real-time systems. So you could still look at a video after the fact, and that kind of processing remains fair game. There's other burdens and potential economic costs. If we looked at the GDPR that the EU put out earlier, there was a lot of worry that small-sized businesses were being affected disproportionately. Some people have similar worries about this current act. Again, it's still a draft, but there's a lot of concerns over it. I realize I went over this quickly. I will try to make these slides available in case folks want to look at that more closely. But I want to talk a little bit about how this affects you, because I think that's important. So we've already talked about how AI is being used more and more in daily life. And just to give you some specific examples, we've talked about all of these before, but I do want to run through them again to reemphasize the point. They're used in facial recognition. You could have walked by a camera today that might have identified you with a facial recognition system, and you wouldn't know it. There's a lot of surveillance systems going on. New York City actually thought about putting surveillance cameras in their subways. There was a whole thing about that. The recommendation systems and search algorithms that remain on Google, Facebook, other platforms you might use are ubiquitous. The smart devices you have and other utilities like photo apps also use different types of AI systems. if you find yourself interviewing for jobs anytime soon, you might find yourself having to record a video that is then analyzed by an AI algorithm. And we're also seeing automation of existing jobs and technologies. In terms of what you can do if you happen to care about some of these issues in responsible AI, I think it's a really important idea, at least to just be generally aware of what's going on as AI systems become used more and more in our everyday lives. I'm glad that so many of you have come to watch this talk today. I hope that it gave you a brief overview of what's going on. It's a good idea to understand how AI systems are used around you and at work, even if you don't work in a capacity as an engineer or where you're working directly on AI systems, those might find their way into your workplace. Advocating for more voices and perspectives in developing advanced systems is a really key idea. I think the whole human-centered design component of developing AI systems is one of the most important aspects. We don't always think about the people who are going to be using it at the end of the day. And so that can restrict the amount of people that the AI systems we develop are actually useful for. It can be great, especially as someone coming from Harvey Mudd and a fairly technical person, to help clear out misconceptions and help others understand the abilities and limitations of current technologies. If you want to learn more about social issues, even independent of how AI systems work, that's really great to understand, just to give yourself a sort of grounding and base upon which to think about some of the ethical and societal implications here. And finally, if you are interested in learning more about this, I think that the AI alignment community has a lot of really interesting things to say just about the potential dangers and failure modes of AI systems and what that tends to look like. And a lot of that, I think, has import into many of the discussions we are having about these systems today. So I'd highly recommend following that. I think we're probably going to go into Q&A now. We did get one pre-submitted question, and I thought this was a really fun one. So I actually prepared a couple of slides in advance. This is going to be kind of the Q&A section of this. So I would like to get into that now. And so the question was about this whole concept of artificial general intelligence, which is always a fun discussion. I haven't really talked about that much throughout the talk, but the question was, do we anticipate artificial general intelligence becoming a reality? If so, how soon could we see it? And what are some of the implications for individuals? And if not, what does the pursuit itself present in terms of ethics? And before going about answering the question, I thought it might make sense to clear up what exactly we mean by artificial general intelligence. I think that different people might have different ideas in their mind when they talk about it. So first, I'll define it the way that I see it. I thought that the favorite definition that I have of it comes from this great New York Times interview with David Chalmers. And it's basically a system capable of performing open-ended tasks independent of specific problems and contexts. So most of the AI systems we use today are relatively narrow. We put them in a specific situation, like identifying faces, like playing a game of chess, and they're existing within a specific problem context. Independent of that, we can look at things like conversation, common sense reasoning, or experiential learning. So that's kind of the way that I want to think about what an artificially generally intelligent system looks like. In terms of whether it's actually possible or not, I think this is something that's still kind of up for debate, and there's different opinions here. I lean towards the yes answer on do I expect it to happen, especially given some of the progress forward we've seen. And there's a lot of people who are very interested in kind of making this happen. And so I suspect, given the amount of brain power that's dedicated towards it, there's a good chance that we might see more and more generally capable things in the future. But I do want to address at least one kind of counter argument here. And there was a paper that came out, I think, in 2020 that claimed that artificial general intelligence can't really happen. And the premise of this argument was something of a sort of metaphysical consciousness style argument that talks about how AI systems aren't in the world. So I want to give kind of an example here. If you think about a language model like GPT-3, it can generate plausibly human sounding sentences, paragraphs, articles, and it's very cool. But what's interesting there is if you think about what's going on inside GPT-3, at least to our understanding right now, the words that it writes probably don't mean anything to it, and the way that the words that you and I speak mean to us. So when I speak about a book or a pencil or a dog or a cat, my interpretation of those words is grounded somehow in my conscious experience of the world. And it's difficult to say that an AI system has the same ability to connect those sorts of words and concepts to its conscious experience of the world. If you look at a lot of the early language models and systems like that, it really reduces to numerical vector representations of words and sentences and things like that. And it's hard to make a claim that that is in any way equivalent to having a subjective experience of the world around you and interpreting language in a way that relates to that. But I think that this whole sort of conscious experience, subjective thing is maybe not so important to this debate, just because if we look at what an artificially generally intelligent system is, at least the way we talked about it on the last slide, I think the definition that I presented there talks a little bit more about its behavior. Now, if your view of an artificially generally intelligent system is one that has subjective experience, then I think you've got your answer. Probably not, unless you buy arguments about consciousness like substrate independence, the fact that you could develop a reasonably complicated circuit or neural network, and then maybe consciousness arises in it as some kind of emergent phenomenon. Maybe you end up creating something that is very similar to the brain. If we look at, though, arguments for it, Chalmers definitely thinks that we can achieve something like an AGI. So just the way I think about it, he kind of claims that intelligence is a matter of the behavioral capacities of these systems. And even if we look at the AI systems we've developed today, we're seeing trends towards that. So DeepMind recently, very recently, actually released a pretty interesting paper. And this was along the lines of doing the same things that we did with GPT-3. So what they found was that they trained a number of reinforcement learning agents. And since I haven't defined it yet, a reinforcement learning agent is capable of learning to perform a task, like winning at a game of Go. And really all it does is it is put in an environment like a game of Go. And it makes actions in that environment. And each action it makes puts it in a new state. So a state might be a certain configuration of the Go board. Each state has a corresponding reward associated with it. And so this reward tells the algorithm whether what it's doing is in the right direction or not. So in the game of Go, if it ends up in a configuration of the board where the algorithm has won the game, then you might give it a positive reward. If it loses the game, you might give it a negative reward. Now, using this whole idea, DeepMind has really pushed forward, I think, the field of AI just a lot. Their founder, Demis Hassabis, thinks that reinforcement learning is going to be the way towards general intelligence. And in this recent paper, Generally Capable Agents Emerge from Open-Ended Play, they found that by putting agents in this environment where they were able to make them play a whole bunch of different games. So these were kind of humanoid creatures in some sort of environment where they were able to play things like tag and hide and go seek and maybe soccer. By training them on a whole bunch of these games, they found that over time, these agents exhibited an ability to learn and pick up new tasks, so to play new games that they had never even seen before, and in pretty short order. And not only that, but they exhibited characteristics that you might think of in a human who is learning something new. They explored, they cooperated, they tried out new things, and they're really calling this kind of a step towards general intelligence. I'm a little bit skeptical to say that it's a major step forward. You can live inside a very small environment inside the universe and think that you're the king of everything just because your reach, the things you see, only expand a certain amount. So it's hard to say how much of a step forward this is, but it's at least an interesting phenomenon to occur. Their reward is enough paper is really kind of a rehash, I think, of a lot of the arguments around why reinforcement learning might push us towards general intelligence. I'm personally of the opinion that the claims in it are kind of meaningless. As much as I admire the work of their researchers and people like David Silver, I think that there just isn't a lot of important stuff going on in that article. In terms of when we might expect to see AGI, so, I'm not an expert on this. I'll give you a random estimate. So I'm going to say 50 years, but my error bars there are also going to be about 50 years. So honestly, I don't have a great idea. If you look back at a lot of the folks who write about AGI and superintelligent systems like Nick Bostrom, one of the key features of getting to a point where we achieve general intelligence or superintelligence is that we might actually not know we're there until we're right at the precipice. So that's one thing to keep in mind. It's hard to know. But if we look at this poll of a couple of different groups of AI experts, if we look at the sort of combined group, people think that there's maybe a 10% chance we could see it by 2022, 50% by 2040, and 90% by 2075. So at least among people who are probably sort of experts, that gives you a sense of when you might expect something. But I think that the AI community also has a bit of a tradition of over-promising and under-delivering. So I often take these kinds of things with a bit of a dose of skepticism. Now, the last part of that question was around the ethical implications. I realize I already spent a really long time on this question, so I'll go through this a little bit quickly, but I think there's many different components to that question. I'll stop before talking about superintelligence, but I'll talk a little bit about the ethics of using and creating AI. So ethics in using something like a general intelligence are things that are pretty much already present today. So we think about the predictability and corruptibility, transparency, and value alignment of these systems. So can we predict what they're going to do? Will they be modified in ways we don't expect? Can we understand that they're doing the right things for the right reasons? And do they have values? Are their objectives similar to what we want them to be? In terms of creating something like an AGI, we can start thinking about the moral status of the machines. So do they have sentience? Do they have some kind of experience of the world? Do they have sapience, a higher intelligence or self-awareness? There's also arguments that Bostrom and Yudkowsky talk about in terms of non-discrimination. So if we believe that someday we're going to develop machines that have some kind of conscious experience, then they might have that independent of the particular substrate they're in. So if you think about silicon, machines producing some kind of conscious experience, well, that seems equally valid in terms of its moral status. Similarly, the paths to existence. So just because I created an AI system versus it being naturally born among humans, if it has conscious experience at the end of the day, that's really all that matters. So there's a lot of different kinds of ethical questions we can think about there, especially if you buy the idea that at some point we might develop a system that has some kind of conscious experience or qualia. These are very, very tricky debates, and it's really hard to make any meaningful claims about them right now. But I hope that answers the question in terms of giving you a sense of some of the ethical ideas there. That's all I've got. So I'm going to go ahead and stop sharing.
Oh, thank you, Daniel, so much. We do have one other question that I do want to mention because we are running out of time, so this will be our last question. How did you think of your audience's technical ability when writing your book?
Yeah, that's a good question. So I guess the one thing I didn't talk about was that I've also been sort of working on a book around a lot of these ethical and societal questions around AI. And I guess, the goal for that book is to be directed towards a pretty general audience. So it's pretty non-technical. I don't expect folks who read it to know anything about how ML systems work. So it's pretty approachable. If any of you in the audience wanted to give it a read, I'd be more than happy for you to. Should be pretty understandable.
Great, thank you. For all of you who still have questions for us, I do see some have submitted. I will send them to Daniel, and hopefully Daniel will have time to respond back to you. But Daniel, I want to thank you for joining us today and for sharing your knowledge and insights with us. Thank you to our audience for your questions and for attending this event. We will follow up within the next week with the recorded video and any presentation material. So be on the lookout for that. Also, we are currently looking for speakers. So if you are interested in being a Mud Talk speaker, please contact us at alumni@hmc.edu. Future events can be found on our online offerings page using the link included in your confirmation email or by visiting alumni.hmc.edu and clicking on online offerings. Thanks again for joining us and have a great night, everyone. See you next time.